The idea of using core states of things like atoms, similar in the way that we manipulate bits in computers, is a fascinating one. It allows for more precise calculations. These calculations at one point were thought to be impossible, but now seemingly possible and a lot easier. Quantum computing would allow us to take a peek at Schrodinger's metaphorical cat and thank goodness not kill it this time.
The quantum computer, for years just a theoretical idea, has recently become computer science's most important invention. The importance of the quantum computer is staggering. Although they have managed to build a silicon-based quantum bit, according to Andrew Zurich, it could still be 20 years until a quantum computer could really do useful things. The qubit allows the superposition of 0 and 1 and all states between at the same time, allowing millions of operations to happen simultaneously, whereas the traditional computer only allows for zeros or ones and only allows one operation at a time. When the quantum computer is built, the technology will do things we previously could not conceive. Things like predict and control the strength of fabric or create complex pharmaceuticals, which until now were built on the basis of trial and error. Historically speaking, the idea of a computer that is able to work with atoms rather than electrons has been around since the early 1970s. With the help of some key physicists, we are closer than ever to actualizing this machine. The concept of quantum computing was initialized in the 1970s and 1980s, largely as a result of three men, Richard Feynman, David Deutsch, and Paul Benioff. Feynman for his talk in 1981 at the first conference on the physics of computation, where he proposed a basic model for a quantum computer. Deutsch in 1985, who described the first universal quantum computer, and Benioff for his proposal of the first identifiable framework for a quantum computer. Regardless of framework and models, algorithms still needed to be invented. These came in the form of Peter Shor and Loeb Grover. Shor discovered the factoring algorithm that allowed a quantum computer to factor larger integers quickly. The downside of this was that it could potentially break down many coding systems. Grover invented a speed-up algorithm which sped up the searches that had to be random. Isaac Chang was the first to put these concepts together in 1998, and at IBM's Almaden Research Center created the first working 3-qubit nuclear magnetic resonance computer. More recently, in 1995, scientists began attempting to run experiments with magnetic fields. This caused issues because using magnetic fields and atoms together makes the electron part of the atom line up with the magnetic field, which influences the spin of the electron. This makes it difficult to work for the quantum computer. Nuclear magnetic resonance was the perfect solution for creating a quantum computer. It creates a strong static magnetic field that doesn't interact with the electron in the atom and creates a rapid rotation. What was so interesting about nuclear magnetic resonance was its capabilities and how they interacted with the quantum computer. It single-handedly dealt with all previous issues in making a working product. There are 6 criteria that need to be filled for a quantum computer to work. They are filled by nuclear magnetic resonance, and they are a quantum system with qubits, individually addressable qubits, 2-qubit interactions, long coherence times, initializing the quantum system to a known state, and extracting the result from the quantum system. The potentials of having a computer that is able to do millions of tasks simultaneously is both easy to grasp and hard to imagine as well. The idea that there could be a computer able to perform equations not seen or thought of in a matter of minutes is an amazing concept, and one that already has the government and military very interested. Heisenberg's uncertainty principle states that you can measure either a particle's position or its velocity, but not both. This theory is potentially debunked by quantum computing. Snooping on a quantum message channel would create an unavoidable disturbance, alerting both users of a change in position and velocity. This is because the state of a quantum computer is unknown before measurement. Because of the potential capabilities of a quantum computer, there is great possibilities to teach the computer things like artificial intelligence and how to simulate a brain. Regardless of the potentials of quantum computers, the model is still very hard to understand. You almost need to have a degree in physics to understand the main theories behind it. The aforementioned use of an atom rather than an electron means they are able to create qubits which, rather than act as a 0 or a 1 in a regular computer, act as a continuum between 0 and 1 simultaneously. In essence, they are infinitely faster than a regular computer and can compute calculations which would have never been possible before. When the answer is located, it collapses into one state and the calculation is made. Because the computer model is now dating back to the 1970s, seemingly every year exciting new developments are invented. Things like the first quantum chip or the first quantum simulator. A quantum CPU has recently been developed. They have created this by making a quantum integrated circuit that has 2 qubits, a quantum communication bus, 2 bits of quantum memory, and a resetting register. All of this means they are now able to simultaneously perform many quantum calculations. A quantum simulator can simulate interaction between hundreds of quantum bits. This will mimic, mathematically at least, quantum systems that wouldn't normally be studied in the lab. Unfortunately, to truly test the quantum simulator, you would need a working quantum computer. A regular supercomputer isn't powerful enough to test this.
The implications of the quantum computer are as vast as they are influential. As you can see, Schrödinger's cat is alive and well and ready to pounce on the world.